certain concepts are important, which is eventually that is just to be that is just needed to be understood. That's it. If you can understand that much, you can attempt the problems and all this. Okay. So yeah, that's it. So I think we can start our session. Share my screen. Okay, you can see my screen, right? All of you?
Yes, sir, it has come up.
Okay. All right. So, can anybody tell me what is there in week 5? What are the contents of week 5?
Uh, it started, but I have seen that it's talking about functions and all the related theorems, various types of functions.
Exponential functions.
Yeah, it's about exponential functions, right? So what in that specifically? Okay, first you will understand what is an exponential functions. Then what more? What all things you know that is there in week 5? First is like definition itself. Let me say I'll write exponential. Okay, maybe I'll just run. Then what else? Did anybody go through the content? Or did you start? Anybody did start like week 5?
Yes, sir.
Yes, sir.
Oh, good. So what is there next?
One-to-one functions increasing and decreasing.
Okay, so these are
Exponential functions.
okay. So you can say this as exponential functions. Fine. So this is like special. So exponential function, it's like you can instead of saying exponential functions, maybe you can say natural exponential functions. What else? What else?
Composite functions f of g of x, gy f of x.
Okay. Okay, that is there. So those things are there. And before that, there is certain concepts like horizontal line test and vertical line test, right?
Vertical line test.
Right.
One-to-one function.
So horizontal and vertical line test. So I'll just simply write. This is not a big thing, but you can just see that I think even I would have discussed this in some of my live sessions already. So that is something an observation I would say. Okay. And what about what else? Yes, one is this.
Opposite functions and inverse functions.
Right. That is the last concept, I guess, right? Composite or composition of functions and then inverse function, right? Inverse of a function.
Yes.
Inverse of a function. So these are majorly the contents of your week 5. Okay. So what is really important here is, first of all, you should understand, in fact, everything is important. But one thing which will be carried forward is this composition of functions, right? And inverse of a function, yeah, slightly because this is somehow related. So you can say this. And of course, knowing first what is an exponential function. So these are very important. This composition of function is very important in terms of uh, the concept itself, because this concept you will find eventually in so many you will find its application so anywhere. Like you can see it in maths too, because you will see so many things coming up in your maths too from this composition of functions. And as you go further, like in higher courses, you will still find the applications of this composition of functions and this also inverse of a functions, because you will be dealing with matrices and determinants, and then this inverse things plays a critical role. So you should have that fundamental understanding what are these things. And of course, you should know what is an exponential functions. So these are the things like in your higher studies, you will find that these things will find its applications here. Okay. So that these are the things. So majorly, these are the concepts which we are going to discuss. So before going further, do you have any doubts, or like, do you want to ask anything for me? Okay. So should I assume no doubt, nothing? Should I start this session then?
Yes, sir.
Okay. Fine. Fine. So let's start with the thing. So first of all, what is an exponential function? So whenever you study a new function, right, you must know what it is first. Okay. Can anybody tell me what is a function? Anybody?
For every input, there will be one output.
Okay, that is one condition. Then,
It's a relation defined.
Function is very.
try.
Please go ahead, sir.
Yes, please. Go ahead again.
It's a relation defined on Cartesian product of two sets.
Okay. First of all, yeah, okay, fine. It's a relation defined on Cartesian products of two sets. Okay, fine, agree. But again, there should be some condition, because in that case, then all relations would be functions, right? So one condition was somebody telling that all the elements of your domain set should be mapped. What is the other condition?
Range
Uh,
domain should be defined.
One input, there should be one output.
Okay, yeah. So that is yes, yes. For one input, there should be one output. There shouldn't be two output. If two output, then it is no more function, right? So understand this. So first, it's basically what function is a mapping from set A to set B. Essentially, this is the thing with two conditions. Okay, so I can just simply say that I'm just starting with the functions because function is a part of your week one syllabus. That's why I just thought, I can just tell you more about this. So function is a mapping from set A, or maybe instead of saying set A, I can just simply use the word function is a mapping from domain set this is our set A to codomain set. Codomain set, let's say this is B with two conditions. Or instead of with two conditions, it's essentially it must satisfy two conditions. So what are those two conditions? First is all the elements of domain set should have image in codomain set. Okay, I hope you understand this.
Yes, sir.
Okay, what is the next condition?
For there should not be two.
So
For every unique
Yes,
input, there should
for
be a unique output.
every
so element of domain set, that is, let's say A, should not have
more than one image.
should not have more than one image. And where this image, you will find it where? More than one image
In codomain
codomain.
set.
Okay. So this is the thing. So eventually, if some of you are thinking, what is that I'm talking about? So let's say, recall that you have studied in week A that this is your set A and this is your set B, and your elements are, let's say, 1, 2, 3, and you have another elements such as, let me say, A, B, C, and D. Okay. So now these are the elements. So first of all, a function is a mapping from domain set to codomain set. So this set, basically this set A is called as domain set. Okay. This is domain set and this is your codomain set. Okay. So now these are the things that you have to understand, that this is a mapping. So you are basically mapping these elements to B, but with two conditions, that these are the two conditions that it has to satisfy. But okay. So but that mapping is again which kind of mapping? Is it a linear mapping? Is it a quadratic mapping? Is it a polynomial mapping? Is it an exponential mapping? Is it a logarithmic mapping? Like it can be any type, right? So this is the thing that we have to understand. All right. So like what kind of mapping it is? So mapping is essentially, you can think of this as a machine wherein you are giving input from set A and you get output in set B. You get output in set B. So I'm saying in set B. There might be some elements in B which is not mapped. That is allowed. But all elements of set A should be mapped. And this mapping is going like this. So this function, what you think of, this mapping, basically this function does that mapping, right? So this function, you can think it as a machine. This machine takes the input from A, and it will take all the inputs. It will take all the elements of A. Okay, it's not like it can leave some element. It has to take all the elements of set A and throw the output in set B. Okay, it should throw the output in set B. Okay, but there is no hard and fast rule that all the elements of set B should be mapped. Okay, so this is the main condition. All right. So now, having known this, now let's say if this is the mapping, now tell me, does this mapping represents a function? Let's say I have a mapping and I get the element, let's say 1 comma A and 2 comma B. So is that mapping represent a functions?
Yeah, it
No,
satisfied both
no,
the
sir.
conditions, sir.
No, sir.
How do
Three
you say
has
it
been
is satisfying both the
No,
conditions?
sir.
So each, okay, third one is not having.
Yeah. First of all the elements of domain set should have an image in codomain. Well, all the elements are 3 is not mapped. So because of first condition, this does not represent a function. Okay. Now, this is about this. Well, if I have mapping, say something like this, does this represent a function?
No, sir.
No,
No.
it doesn't represent.
Why?
The second condition, each element of A can have only one
Can have
One
image
input
in its
has two different output.
outputs.
Yeah. So one input has two different outputs, and therefore this does not represent a function. Well, can you list? Can you tell me what are the elements? 1 comma A, 2 comma A, 2 comma B.
Comma
Look at
B,
this. Look at this.
3
2 is
comma C.
mapped to 1 A and 2 is mapped to B. So, in a question, we can even give it like this. We might give you a relations like this, and we might ask you that does this represents a function? Does this represents a function? Okay. So this might be the question, right? We can ask directly like this. So all you have to do is just notice this. This 2 has got two output, therefore this does not represent a function at all. Right? That's it.
Yes.
Okay. So this is something very important from your quiz or qualifier examination point of view. Okay. So pay attention. Just make a note of this. Okay. So you should be thorough with this part because you never know, a question might come up like this. Okay. And then you have 3 comma C. Okay. So I'm least bothered whether this D is mapped or not. It's okay. Okay. So just for a quick knowledge, let me understand if this mapping was not mapped to A, right? Okay. Could you tell me what is the range for this? Quickly, just tell me.
A, B, C, D. A, B, C.
So range is from least value to the most value. Well, range set is the right thing to ask. So what is the range set here? You get A, B, and C,
C.
right? But D is not mapped. But what is your codomain set? A, B, C, D.
Yes.
Right? Your codomain set is A, B, C, D. So is your range equals to codomain?
Not necessarily, sir.
No.
It is
In
not equal.
this case, no.
Since it is not equal, therefore, can we call this as onto function?
No, no, sir.
We cannot call this as an onto function because when do you say onto function? When range is equals to codomain, correct? But is this one-to-one function?
Yes, sir.
It's a
Yes.
one-to-one function.
Yes. So, well, I'll not get into one-to-one function much deeper here. We can see that later on. So, well, I can understand that what is this function. Now you understood, right? All of you understood?
Yes,
Yes,
sir.
So now I was talking about this mapping, right? Can you tell me what kind of mapping is this? Is this a linear mapping? Because, okay, forget about the linear mapping. When I have some real data, then you can understand whether it is linear mapping or not. So what I meant to say is this function f, which is mapping this set A to set B, right? It takes a nature, it takes a form. It can be a straight line type. It can be, basically quadratic polynomial and whatsoever. It can be so many, it can take any form, right? This mapping. But all that matters is that it will take elements from set A and it will map in set B, right? This is the main thing. And for it to be function, these two conditions, definitely it has to satisfy this and this. Okay, clear? Okay, so this
Yes,
was
sir.
brief about what was functions. Now let's get into an exponential function. Okay, so what is an exponential function? So as I was talking about the mapping, so here this mapping is something like this. Okay, so now basically, can somebody tell me what is an exponential function? A function f of x, which is written in this form, a
A
to
to
the
the power of
power of x. Okay, so whenever you write a function, you have some kind of restrictions. Okay, what about what can a be?
more than
A is greater than
0,
0 and a should not be equals to 1,
1.
right?
Yes.
It is not defined because if a becomes negative, right, you have a possibility that it might becomes a complex number, and we are not dealing with a complex number, and this function is not defined like that. So the definition of function is a function is equals to basically a function of this form, a to the power, or not a function but an expression of this form, a to the power of x, where a is greater than 0 and a not equals to 0, a not equals to 0 will form a function. Well, what about x? X can take any
This is
real values.
any real values.
Okay, so x can take any real values. Okay, so whenever you write a functions like this, you define a function. Now as am I telling you that x belongs to a real value, I can blindly say that, since what is this x represents, it represents, now if I have to tell you, I was talking about this Venn diagram, right? Not the Venn diagram, but this arrow diagram when I was telling you. So I was talking about set a, right? This is set a, basically x, and what you get here is your, let's say this is your y.
F of x, right?
Y. Okay, so essentially this x represent your x axis and y represents your y axis. Okay, so I can say this function is mapped from R to R. Okay, this function is mapped from R to R. Basically, it can take all real values in where, in set B, that is your y, which is what, all real basically, right? You can understand now? Understand?
Yes, sir. Yes, yes,
Okay.
yes.
Okay, so now you understand this. Now we understood that it takes all, so this is basically your domain set and this is your codomain set, right? So now we understood that x is basically my domain. So x is all real. Basically, it can take all the values from minus infinity to plus infinity. You can have all values like minus 10, root 2, or 0, 1, 2, whatever. Okay, and over here the mapping is something like that, that over here the output, so this, since this is codomain and it is real, so it can have all the values, right? But you don't know what is the mapping, how is its nature, right? So that is something we have to understand. Okay, so now let's do some mapping. Okay, let's say if a is equals to 2. Okay, so I'm just saying it in a crude way so that we can just simply understand. Okay, so now if a is equals to 2, so I can say it as 2 to the power of x. Okay, so if a is 2, so could you tell me the mapping over here? If x is, now x can take any values, right? So let's start with the 0. If x is 0, what do you get output?
1.
1,
1. If x is 2, basically if x is 1, then what is the output you get?
2,
2, right? If x is 3, what is the output you get?
8.
8, right? So basically you get the output, if it is 3, you get some 8 value, so it's going to be something like this. Okay, and what if it is if x is, let's say, minus 1, what do you get?
1.
1 upon 2. 1 upon 2 is what?
0.
0.5.
0.5. If you take, if x is equals to minus 10, what is the output? It's like 2 to the power of, sorry, 1 by
10.
To the power of 10.
1 divided by 2 into 2 into 2 into 2, 10 times. 2
Or 10.
factorial.
2 to the power of 10. So if you calculate, this value is also what? Some positive value very near to 0, right? So even if you take this thing, it will be mapped here. So no matter what negative value you take, it will be mapped from here to here. And these values are not mapped, right? So you see
Yes.
this, I was talking about mapping, right? So how are you doing mapping? You are using this functional mapping, right? So you are using this function as a mapping. Now look at this. Is this first of all, I'm claiming this is a function. Look this exponential function, right? So if I'm claiming, then it must be obeying this function definition. So what was function definition? It is a mapping from set A to B, where set A is what? X, and set B is Y, with two conditions, right? What was those two conditions? First condition is all the elements of set A should be mapped. So you notice that all the elements of set is being mapped, right? And you will also notice it is not uniquely mapped, right?
It
Sorry, it
is
is unique. It
uniquely
is
mapped.
uniquely mapped. Basically, all the elements of set A has got a unique image in B, right? There is no two images. So you understand that. So it is fulfilling the condition of function. Clear?
Yes.
All of you clear? Yes. So having
Yes.
known that yes, whatever the function we studied, this is definitely fulfilling that condition. And we also try to do this mapping thing, this exponential mapping. And so we have a now idea about this thing. Okay. So now let's dig more in this exponential function, that what all things we can do. Okay. So now I'll just erase this part. This was, why am I telling you this basic is because you have your qualifier exam. So that's why, I'm just touching upon your some of the basics so that you can have some sort of revision. Okay. So that's why I'm doing this. Don't think that I'm dragging it more. This is somewhat important. So I'm just from your week one perspective. That's why I was telling you all this. Okay. So now let's go much deeper into this and understand. Okay. So before going further, we understood a expression of this form, that is a to the power of x, when a is greater than 0 and a not equals to 1, is basically an exponential function where x can take all real values. Okay. So this is what this represents an exponential function. All right. So now, before going further, make a note of few things. Okay. What is a to the power of 0?
1.
Right? So you can make a note of this, where this a is falling under this range. What is a to the power of infinity? Infinity. What is a to the power of minus infinity?
0.
0. Okay, so make a note of this, because when you are dealing with an exponential function, you will be highly dealing with all these things. Okay, clear with this? So now I'll
Yes.
just erase this part as well, because this is just something I wanted to tell you, that this is something can be used in your when you're solving a numerical. Okay, so now before going further, yeah, not before going further, but let's go further and see that, okay, what is this exponential functions? So first of all, like I always tell you, that whenever you deal with any function, you must know what is that, which expression is basically called function and what are the conditions. So this expression is called as an exponential functions with these conditions, right? Okay, so having known these things, then what is the next thing that you should always keep it in your mind whenever you study a new function? The next thing is the graph. How does the graph look like? Okay, that is the next thing that you should know. So then let's see that graph part. Okay, and let's understand how it is happening. Okay, so now let's say our function f of x is something like this. Okay, we'll just write it down. What is a to the power of x, and over here I would like to say, so now you can notice that basically when I'm talking this, if I have to express this on a straight line, how will that thing will be? If I say this is your a, okay, so basically what you see, a is greater than 0. Well, I'm starting with this 0, so a is not included, right? And I'm going till where? I'm going till a
1.
equals to 1. So well, this is 1. Keep this as 1. Well, 1 is included? No. And then
No.
it can take up to the infinity. So this is what the condition. So what is the range value that I see? It is similar to saying that 0 comma 1 union, what more? 1 to infinity. So essentially I'm just rewriting this condition like this, right? So now I'll just take up that condition. So what do you notice is, here a is in between what? 1 to 0 to 1, right? I can say this, right? And when a is greater than 1, right? These are the conditions that I can see, right? Right, so this is one thing that I'm trying to draw here, but let's understand this, what is happening. Okay, so first of all, let's see what is the graph itself. How will the graph look like when I'm taking this interval? So if I have to give one example over here, example a is equals to, let's say, half, right? A can fall in this range, and over here I can give an example, a is equals to 2, 2 to the power of x, half to the power of x, right? 1 by 10 to the power of x. Okay, so if I say 1 by 10 to the power of x, it will fall under this interval, correct?
Yes.
Okay, so now let's get into the graph part. So how will the graph look like? So graph is something like, how do you plot the graph? You take the value of x and you take the value of y, right? That is in your hand how you take it. You can take any values and plot the graph. Well, just for the simplicity, I will simply draw the graph for this so we can have an understanding that how does this look like, okay? So this is the graph for So this is the graph for this interval. So over here, let's say a is half, or you take it a is 1 by 10 or 1 by 50 or whatsoever. Okay. So you take it, but it should be in this interval. You will see the nature of curve is something like this. Okay. It's always going to be like this. If this is x and this is y, let's call this is f of x, where you know this a is half. So maybe I'll just simply write down half to the power of x, or you can simply say a to the power of x. So all of this curve will be in this nature. It is going to be in this nature. Okay. And what about this curve? What about this range when a is greater than 1? How will the graph look like? It's something going to be like this. Well, this is right. It's going to be something like this. Okay, so you understand this, that the graph of this exponential function is of two types. When I distribute into two intervals, because this was one interval, in this interval the graph characteristics is going to be something like this, and in this interval the characteristics of graph is going to be something like this. So could you tell me, what is the range of this particular function? Tell me what is the range of this function?
It's always 0 to infinite.
Correct. What about others? Your understanding when I say what is a range? Range is the set of y values, isn't it? This function which is giving us. How do you understand set of y values? Basically, where all these y values are, because no matter what x value you take, how bigger the x value you take, it is trying to approach to 0. So that approaching 0 is the output, right? And if you take the least negative value, it's actually magnifying the f of x value. So that is the most value, right? So what is the range you get? It is trying to approach to 0. So the least value is 0 and it is trying to approach. It's not giving me 0. So 0 is not included. What about this? What is the value you get over here?
Infinity, plus infinity.
So infinity. So this is increasing, right? So 0 to infinity is the range, and 0 and infinity both are not included. Okay. What about this? What is the range?
Infinity to 0 to infinity.
This is also 0 to infinity. Because over here, if you take the least x value, you will approach 0. You will never be 0. Okay. And this, when it is increasing, as you increase x, so this is increasing type, right? Okay. So having known this range, what is the x-intercepts? Could you tell me what is the x-intercepts of this function?
There is no x intercept at all, sir.
So basically there is no, so I can say it's nil, right? There is no x-intercept at all, right? All of you clear with this? What is y-intercept for this?
1.
Okay. It's just that simply put this, when x is 0, what do you get? X-intercept, sorry, y-intercept. So this is half to the power of 0 is what? 1. So essentially I can say that yes, it is going to be 1. And over here, it is going to be 1. So if I just have to write it in a coordinate way, I can say that 0, 1. And I can say this 0, 1, right? Okay.
Yes.
So y-intercept for both are same. Understand that, okay? Okay. So now having known this, okay. So now what do you mean by
One small question regarding x-intercept, not related to exponential function, but generally for an equation, if we have imaginary roots like not real roots, so do we consider them as x-intercepts? No, right?
come again, please?
Complex roots, if we have,
Okay. Complex
like,
root will not consider.
will not consider them as x-intercepts, right?
Correct. We will not consider.
Okay. Okay, thank you.
Okay. Yeah. Okay. So now before going further, I just want to introduce one more concept here. This is called asymptote. Okay. I hope some of you might know this. What is an asymptote? Okay.
The graph goes to 0 but does not touch the 0. The y asymptote called.
Okay, so let's understand this. So basically, I'll just maybe for others also, I'll just simply write it down here. So an asymptote of a curve, a asymptote an asymptote of a curve is a line. So what is this basically? It is a line, okay, such that, so it is a line, but there is a condition such that the distance between the line, the distance between the line and the curve,
Sir,
and
curve,
the curve, yes,
line and curve, sir.
yeah, line and the curve approaches zero. Okay, so now let's understand this. Before going further, just understand this. Okay, so I'll just explain you this asymptote and then I'll bring you here, okay, to our main thing what we are discussing. So now look at this asymptote thing. What I'm trying to do is, so this asymptote is something like this. So asymptote of a curve is a line such that the distance between the line and the curve approaches zero. Okay, so now look at this curve.
Sir,
Let's
can
say,
we say that asymptote is tangent at infinity?
see again, saying it as a tangent is a wrong word, uh, because see, tangent touches the curve, right? At one point in a given interval, right? In a small neighborhood. So let's understand this. So let's understand this first, okay? So now what is happening is, look at this curve, okay? So this is my curve, okay? So now understand this. So what is an asymptote of a curve? It's basically a line such that the distance between the line and the curve approaches zero, okay? So now if I have to draw any line, first let's draw a horizontal line and see if there is an horizontal asymptote or not. If I draw a horizontal line over here, this cannot be an horizontal line because you see the distance between this line and this line is actually touching here and it is zero, right? This is one point where it is becoming zero, isn't it? If I have to ask you what is the distance between this line and this line, you would say, okay, fine, at this point it is zero, right? So essentially it should not cut that curve, okay? So that is one understanding that we can make. So this cannot represent a horizontal line. What about this? Again, it cannot, I mean, asymptote. Even this cannot, because it will eventually cut this x-axis, I mean, this curve, right? And then if I have to ask you what is the distance between this line and this point, at this point, you will say zero, right? You understanding? Right?
Correct, sir.
So essentially, I will not have any horizontal asymptote because this is an increasing function. I can always draw any line which will cut that curve, right? Now look at, I'm done with the horizontal line. So basically this curve does not have horizontal asymptote, right? Now look at vertical asymptote. Now if I have to draw a vertical line over here, look, it will cut this curve, right? So what I'll do is, maybe I'll not draw here, but not over here because it will again cut the curve. Now look at this. If I have a horizontal line on y-axis, let's say my horizontal line is x is equals to 0, right? If I say, if my horizontal line is basically my y-axis itself, then what? So this is basically a line, right? This is basically a line, and look at the distance between them. Initially it was high, decreasing, decreasing. The distance between these two curves are decreasing, right? Decreasing, 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 decreasing. What is it approaching to?
Zero.
It is approaching to zero, right? So this distance is approaching to zero, right? As you go further. So what is an asymptote? An asymptote of a curve is a line such that the distance between the line and the curve approaches zero. Therefore, I can say that for this particular curve, I have an vertical asymptote, and that vertical asymptote is what? X is equals to 0. So clear? Okay. So if not, I'll just do one more curve here, and so that we can understand this better.
Sir,
Okay.
1 second, sir. For this case, we can always say anything less than zero is asymptote line.
Uh, I didn't get you.
No, in this, the nearest asymptote is the y-axis, but anything, any line like -1, x is equal to -1 is also an asymptote for this
No,
curve.
no, no. That is not a asymptote because that will not approach zero. It will approach to it will approach to 1. If I have to draw one line over here, right?
No, after x-axis, one more line.
Let's draw this
That
line.
it is also
Okay.
approach to keep on approaching to zero, no, sir.
No, no,
It
no,
is
no. It is not
the
going to approach
distance.
zero. Wait, it is not going to approach 0. Look at this distance. Okay, fine, it is approaching, but it is not approaching to 0. Look at this. This is trying to get, this is trying to reach x-axis, x equals to 0, right? But look at this. When you find the distance between these two things, let's say this achieves 0, then what will be the distance between these two lines? 1,
No,
right?
it will never, it will never, but anyway, okay, sir. This is the least asymptote. Y-axis will be the least nearest asymptote.
There is no concept of nearest asymptote. It should approach 0. When you draw this line over here, and when you try to measure the distance at infinity, it is going to be 1. When you
Sir,
claim this is x is
One.
equals to 1, right? It will be 1. It will not approach 0.
Okay.
sir, why are we calling this line and not a y-axis?
Because I'll give you another example why I'm calling this. You can call this a y-axis as an asymptote. That is right, because for this particular case, if I had to draw, look at this particular example, okay? The one which I'm trying to draw here. And let's say this is not 1, but this is 10. Do you have horizontal asymptote for this curve?
Mm,
No, we will have
No.
vertical asymptote.
We have vertical asymptote. And where is that vertical asymptote? You see what is happening if you draw any line, let's say a vertical line over here. What do you notice is when you draw a vertical line at 10, what do you notice? Distance was high, decreasing, 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 decreasing. This curve is trying to come to 10, but it is never coming to 10, right? Right? So what will be the distance? It is trying to curve to 10, right? It is trying to come to x equals to 10, right? But it is never approaching that, right? So what is happening to the distance between these two lines? It is approaching to 0, but it is never being 0. So in this case, okay, you can't see my screen, right?
Yes, sir. You can
No.
see, sir.
Yeah, it went blank all of a sudden. Just wait for a minute. Okay, so now it would have come. Okay, so in this case, what is my vertical asymptote?
10.
X equals to 10. Right? Clear, all of
Yes.
you?
Yes, sir.
Okay.
Yes,
So
sir.
now,
Yes, sir. This was only I was telling, sir. Sometimes, I mean, it is only representation of the graph we are showing, sir. So, -1 also can come in the sense if x can take 10 as asymptote, in some other case, -1 also can be an asymptote.
okay, yeah, like that. Like this is how you wanted me to tell, is it? Okay, fine. I understood.
No, no, I was thinking, I don't know. I was just thinking if it's, we don't know what is the function, no, sir. You have just given one line, so that is crossing x-axis or not, whether it will cross y, I mean, -1 or not, we are not knowing. I
But you
was
should
thinking there will be only one asymptote for any curve, that is y-axis, if
need
this
not
is
be
the
there is
shape.
just one asymptote. You can have multiple
So I
asymptotes.
was thinking like that. So that
Okay.
is why I asked that question.
Okay, okay, no problem. But you understood now?
Yeah, yeah.
Okay. So now having known this,
One more thing, sir, observation what I made is, so for infinity, it will never be 0. X infinity, if you put x as or minus infinity for this particular first curve, so that cannot be a 0. It will never be. That is the understanding, no, sir? Am I
then
right?
x is equals to minus infinity
But plus infinity.
plus infinity. It will not be 0. It will be very big value because see this is increasing type, right?
Okay, okay. Approaching x is approaching 0. When x is approaching 0, y will never be 0.
Y will never be 0, but it will be like the very least value. It is tending towards minus infinity.
Yeah, yeah, yeah. I can observe it, sir. Yes, sir. Correct, sir.
Okay.
Okay.
Okay, fine. So looking at this curve, could you tell me what is the domain of this curve? What is the domain?
0 to
0 to infinity.
0 to
Because,
infinity.
because I don't have this curve on the x-axis side anywhere, right? The least value this can take is somewhere near to 0, right? The x value, right? It can take somewhere near to 0. And what is the most value of x that it can take? Infinity, right? But look at this function. Can you give minus 10 to this and ask, okay, what is the value for this function? That is the wrong thing to ask, right? Because that is somewhere it is not defined,
Range.
right? So that is out of the domain basically. Clear? What about this? What is the domain for this?
10 to
10 to
infinity.
infinite.
Okay. So now you understand this. What do you really mean by this domain, range, asymptote, all these things? Somewhat
Yes,
clear?
sir.
Okay. So now
Okay, yeah.
okay. So now let's go to this part, the thing which we were discussing. What can you talk about asymptote for this particular curve?
The curve is going towards the zero, but not touching zero. So x-axis will be the asymptote.
Okay, yes. Well, that is right. X-axis will be the asymptote. Then what will be the equation? Y equals to 0.
Y equal to.
Right? What about this? What about this curve?
Y equal to
Same.
0.
Yes,
Y
it's
equal
also
to
y equals to 0. Okay, so now you understood. So over here, I have what? Horizontal asymptote. Right? Can you think of any vertical asymptote here? No, I cannot, because if I just draw a vertical line, everywhere it is going to cut the x-axis, y-axis. So basically this curve, right? So I will
Except
never
at
achieve.
0.
No. I'm talking about vertical line. So you
Vertical.
don't have
Okay.
basically vertical asymptote over here, right? All of you understand this?
Correct, correct. Yes,
Okay.
yes, yes.
So what is the
Sir,
nature
I
of
have
this
a
curve?
doubt.
Hmm.
You said like curve can have more than one asymptote.
You have more than one asymptotes. So you want me to
How
give
is
you an
it?
example?
Yes, sir.
Yes.
Okay. So fine. Look at this example. All right. Pardon this thing. I cannot. Let's say you have a curve like this. Now, don't you think there are three vertical asymptote here? This is not parabola. Just remember, this is not a parabola. Okay.
Okay, the
So
curve in
whatever.
between, they are not joining at all, sir.
No, they are not joining. Now
Deep
look at
down,
this.
infinity minus y.
I can draw a curve, something like this. It is trying to approach this point, but it is not approaching this. It is also trying to approach this point. It is not approaching this. It is also trying to approach this, but it is actually not happening. So basically, you will find these kind of things for log of x minus 1 times log of x minus 2 times log of x minus 3. If I give you something functions like this, you will find curve for this something like this. Okay. So don't worry, how is this curve happening? If I'm taking any sessions on logarithmic, I'll tell you how to draw the curve for this also. Okay. So no need to worry about this. But all I have to tell you over here is how many vertical asymptotes are here? 3. Okay. So what do you really mean by asymptote then? Basically, what is happening is if you're talking about vertical asymptote, for what value of x the function becomes infinity, right?
Okay.
Right? For what value of x the function goes to infinity. This is what we are trying to ask, right? Right?
Yes, yes.
Yes, sir.
Okay. Because if you look at this curve, for what value of x does this function goes to infinity?
0.
Wait, since this
Y
is
equals to 0.
wait. That is about horizontal line test. So for horizontal asymptote, so forget about this. If you're talking about vertical asymptote, that is the right thing to ask. For what value of x this function goes to infinity? You cannot ask the same question there. So now what? Look at this. When x is 1, right? When you put x equals to 1, what will happen? This will go to infinity, right?
Yes, sir.
When x is, because log 0 is not defined, we say, but it actually goes to infinity, minus infinity side. Similarly, when you put x equals to 2, that is this condition. So if I have to say this is 1, this is 2, and let's say this is 3. So essentially you see at these values, it is minus infinity, isn't it?
Yes.
Right? So you see, though the function is not defined, but you should understand that where it is actually tending towards, right? So since you asked me this question here, that is why I explained it. This is, don't worry if you didn't understood anything here. We will take it up somewhere
Sir,
in week 6.
but the point you just said, for what values of x the curve goes to infinite,
For
it doesn't
vertical,
hold.
for
Yeah,
vertical
it
asymptote.
doesn't. Yeah,
It
it
doesn't
doesn't
hold for
hold good
horizontal.
for this x equal to 10 condition, right?
X
Can you go
equals
to
to
the
10.
graph? X
Sure.
equal to 10. This graph, for what
Okay.
values of x, the curve goes to infinite means for
This is the
x is
curve
equal to
for
infinite.
this is curve for
For
log x
x,
minus 10.
correct,
Whatever the
correct.
curve I have drawn.
Okay, okay. But for this at the asymptote, the curve goes to minus 10, and the curve goes to 10, right? Not infinity.
No, the value. You should look at the values. When x goes to 10, what happens to the
F
value
of
of this curve? What happens to your f of x?
f of x.
Tends to go
Okay.
zero.
That thing I meant, okay?
Tends to go to 10. For x equal to 10, the f of x, okay, f of x keeps going to minus
Ah,
infinity.
you understood now?
Okay. Yes.
Okay. And this condition is applicable for vertical line test. If you go for horizontal line test, then it is not the same, okay? The function definition by which I was explaining you, okay? So now what is the nature of this particular curve? Is it strictly increasing or strictly decreasing? Oh, sorry.
First one is increasing.
First one is increasing.
First one is strictly
Decrease.
decreasing towards zero.
Okay, so this is, yeah, as x increases, as you see, it is strictly decreasing. Strictly decreasing. What about this?
Increasing.
Increasing.
Yes.
Okay, clear with this? Okay,
Yes,
so
sir.
now just a quick question to all of you. What do you really mean by strictly increasing and strictly decreasing? So just I'll give you one counter example so that you will understand, right? So let me give you an example, something like this.
Parabola.
No, not always parabola. Okay, tell me, is this strictly increasing?
No, at some
No,
point it
it
is
depends on
It
the
straight.
is,
interval.
yes,
It
there are
completes.
certain points. Let's say this is 1 and this is 10. In this interval, it is not increasing at all. It is constant. So you don't call this as a strictly increasing function. You can just simply say as a increasing, that will do. But you cannot say as strictly increasing. You understand?
Yes, sir.
Okay. So now let's go to the next part. Now let's discuss what is this end behavior. What is happening? End behavior is basically what happens when x tends to infinity, that is positive infinity, and x tends to minus infinity. This is what the end behavior is.
X tends
Okay.
to infinity, it is going up positive.
So when x tends to infinity, what happens to your f of x value in this first curve?
First towards zero. Y is going towards zero.
So f of x tends towards 0. What about this? F of x tends towards?
Infinity.
So this is very obvious to read from the graph. What happens here when x tends to infinity?
Infinity. F of x is infinity.
F of
Going
x is
up and up and up.
right. And what about this? This tends to 0.
Zero.
You understand now? All of you understood something from here?
0
This is the utmost we can do for any particular function. So are we fine with the functions? We got to know, okay, what is the graph of a function? What is the range of the function? We know what is the domain of this function. We got to know what is x-intercept, y-intercept. We also understood something new called asymptotes. This is something it was not there for other polynomials and quadratic or a straight line, right? You didn't had this concept for asymptote, but you have it hereafter. So this is new concept. Then what is the nature of this curve? Whether it is strictly increasing, decreasing, then what is this end behavior? Okay. So you're clear with this? Shall we move ahead? So we are done with the definition of an exponential function. So this is what something whenever you study a new function, this is the way you should study. First, understand what is the given expression of that particular function. So whenever you say, okay, this is my function, so first you should understand which expression is actually called as an exponential function, okay, or any particular function. Then what is the condition? If there are some variables or like if there are some coefficients, then what are the conditions for that? For an example, when we were discussing polynomial, you remember when we say this, I myself was discussing this when I was telling this x to the power of 5 and I claim this is a polynomial of degree 5. When can I claim this is a polynomial of degree 5? When a is not equals to 0, right? At that time I can say this, right? So there were something conditions always you find, right? So you must know, okay, what is that conditions, right? So this is the conditions. Then what is the graph? So if you remember, we studied straight line, quadratic and polynomials, and we discussed extensively about the graphs, isn't it? So you must know what is the graph. Okay. Now I can do so many things with these graphs. All that you have to understand is, okay, when a is greater than 1, the graph is increasing. When a is greater than lesser than 1 but greater than 0, this is what I see the graph. Once I know the graph, what I can do is I can play around with this. Now if because I know, I can just simply I can just merge exponential and log, and I can ask you, okay, what is the graph for this? Well, you will learn eventually, so no need to worry. So basically you should have an
Basically,
idea.
from this, all exponentials are one-to-one functions, either increasing or
Yes, yes, yes,
decreasing.
yes, 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 yes. No matter which interval you take, it will always be increasing and it will always be like decreasing, or like it's always one to one, right? Okay,
Sir, for
so
regarding one-to-one, I just have a small question,
hmm,
just a step backward.
hmm,
For one-to-one representation, they are using as f of x1 equal to f of x2 implies x1 equal to x2,
correct,
right? Can we
correct.
not reverse this equation?
Reverse, but you have to
Reverse.
apply. You can reverse that, but you will have to apply some. You have to pay attention to some conditions. Okay, but I'll not tell you that conditions. What is that? You can say, but it is not always true. I can give you a counter example, which is always incorrect. Okay, so for time being, just go
Even
with
for
this.
for inequality also, inequality they are using the reverse. X1 not equal to x2, then they are saying f of x1 not equal to f of x2.
So well,
We have such question in one
right, right.
activity.
Okay, so when you are discussing this, when x1 is not equals to x2 implies that f of x1 is not equals to f
It's
of
not.
x2. Well,
Yeah,
that
this
is
equation
right.
we are not able to play with both sides around, like
Hmm,
choosing whatever is the left hand
hmm,
and whatever is the right hand. This
hmm, hmm.
implication was only one-sided, so I was confused. Actually, I forgot to ask this during your one-to-one concept.
Okay, fine. No problem. But for
This
time being, just
activity.
go with this concept. F of x1 is equals to f of x2 implies f of x1 is equals to
Implies
x2. Okay,
okay.
just go with this
This
concept.
is
Okay.
this is an activity 5.1 question number 4, sir.
Okay.
Yes, yes, sir. Activity fourth question, 5.1.
Okay, okay, I got it. So, well, you would see that what is professor discussing there, he would be actually discussing that part. So you can just see from there
Yeah.
at what conditions you can just give emphasis to this. But if you want
Yes,
to ask
yes, sir.
me from,
If possible, try to mention one or two counter examples also, so that
sure, sure, sure.
it will be easy for us to recognize
Sure,
which
we
is
can
correct.
get into those concepts maybe a bit later. Let's get into this flow part. But for
Sure,
time
sure.
being, I would say just go with that, the main thing. F of x1 is equals to f of x2 implies x1 is equals to x2. This is definitely
Yes, sir.
always right. Okay, so go ahead with that.
Sure, sure,
Okay.
sure, sir.
Yeah. So now look at this thing. So now we are done with the exponential functions and all this. Okay. So this was some concept like which you would have seen it, because this is important from your week one aspect also. So you can just say this. You can say this. First of all, what is this horizontal line test? And I can just simply say here vertical line test. Okay. So maybe first I should write vertical, then I'll write down horizontal because it has to first.
Sir, a general doubt.
Hmm.
Like you said, we don't have asymptote for the quadratic and all this. Then why we are studying asymptote for this one? Why is it helpful?
Because there is asymptote in this. That is why you don't had asymptote for that.
But there were lines they were reaching infinity. So,
Okay, but you always have some x value where it will cut that curve,
okay.
right? If
Yes.
you say there is a line, let's say if I have a polynomial something like this, okay, and let's say this is f of x is equals to x cube. It though appears that it is going to infinity and all this, but I can always find some x value for which I can map that, right?
Yeah.
Yeah, it will always cut that curve. So that's why you don't have that concept of asymptote at that point of time. Okay, so now let's go with this.
So for my same thing, just extension understanding, sir. So wherever real root is not available, there you can have one asymptote. Is it correct, sir? That statement what I made?
Yeah, you can say that.
Okay, okay, thank you, sir.
Hmm. Real root in the sense, basically, wherever it is approaching infinity, right?
Yeah, it is not at all crossing the x-axis, no, so there is no real root at all. And that's what I
No,
think.
but over here, when I give you an example, this is,
Not asymptote.
Oh, one place it is touching.
yeah, it is happening. So
Okay,
you
okay.
cannot go that way. Yeah.
So what statement I made is false, wrong.
Yeah, yeah,
Correct.
yeah.
Okay. Okay, sir. Thank you. Thank you. Now I understood.
Mhm. So vertical line test, first understand this. Now let's say I draw a curve like this. Okay. Does this curve represents a function?
No, sir, it does not
No,
represent.
sir.
It does not represent a function. Why? Because let's say this is 2 and let's say this is 1 and let's say this is 3. So you see at 2 how many values I'm getting? At 2 how
1
many
and
output
3.
I'm getting? This
1 and
and
3.
this,
Yeah.
right? So it is eventually, if I have to draw this arrow diagram, so this is 2 is mapped, 2 has got 2 output. Now this validates what? My second condition of my function, right? Basically there are 2 output for 1 input, which is not
Yes.
allowed for it to be a function, right? So even though this curve is a curve of a circle, right? This circle does not represent a function. Okay, this does not represent a function. So what do you really mean by vertical line test? Vertical line test means whenever you draw a vertical line, right, parallel to the y-axis on the curve, okay, and if it touches more than one point, then it fails the vertical line test. Okay, when does it fails the vertical line test? If the curve touches a vertical line at more than one point, then it fails the vertical line test. Okay, so over here, how many places it's touching the curve? If this is my vertical line, how many places it's touching the curve? 2 places. And since it is touching at 2 different places, therefore it fails the vertical line test and it is not a function. So vertical line test tells you whether it is function or not. So maybe I can say this function or not, right? Whether vertical line test tells you whether this is a function or not, right? So this is not a function. Why? Because it fails the vertical line test, right? Okay, now look at horizontal line test. Now, when do you check for horizontal line test? If and only if it is a function. Okay, so you check for a horizontal line test if it is a function, right? So it must not, if it is not a function, then there is no point in doing horizontal line test. So it must first fulfill the vertical line test condition, and then you should go for your horizontal line test. Okay, so now look at this. If I have to draw one curve, something like this, tell me, does this satisfies the vertical? Does it passes the vertical line test? No matter wherever you draw the vertical line,
Yes.
right? It will touch at one point only. It will touch the curve at most at one point, right? Right? So since if this is happening, then you say that it passes the vertical line test and this represents a function. Okay, clear?
Yes, sir.
Okay. So now if that was the case, now let's understand this. Now, what do you mean by horizontal line test? In horizontal line test, you draw a horizontal line. Okay, you draw something like this. To draw something like this, and again same condition, for it to pass the horizontal line test, it must have the horizontal line must, I mean, it should cut the curve at most at one point, right? So essentially how many point it is touching here, or it's cut it 3 points.
1, 2, 3.
So there are 3 points where it cuts this curve, therefore this fails the horizontal line test. Again, this fails the horizontal line test. Therefore, it does not represent one-to-one function. So this basically tells you what? One-to-one function. Whether a given function is one-to-one or not. Okay. Okay, so over here we were checking whether this is a function at all or not over here. And over here we are checking whether this is one-to-one function or not. Okay, so now you understood? So how do you really mean by, what do you really mean by this? So if I have to draw the arrow diagram, now look at these places. Let's say this is A, this is B, and this is C. For all of these, what is the output that I'm getting? Let's say this is 2, right? So if this is my X, so I can simply say A, B, and C, and look at this 2. So all of these, aren't they mapped to 2? Can this be
Yes.
one-to-one function?
No.
No.
Can this be a function?
Yes.
Yes.
Because you see A, B, C all are mapped, and you see A don't have two outputs. It has got only one output, right? But this is not one-to-one function. Understand this? Okay, clear? Okay. So fine. This is all about vertical line test and horizontal line test. Okay. So now if I quickly ask you some functions like this. Now if I have to ask you some functions like this, now look at this curve. Does this represent one-to-one function?
Yes.
Yes.
Okay. Like that, does this curve represent one-to-one function?
Yes.
Okay.
Yes.
So now you understood that why this curve is one-to-one function. Basically, you see this function, what we have, this one, is this one-to-one function? Does this represent one-to-one function?
Yes,
Yes,
sir.
sir.
What about this? Yes.
Yes.
So
Yes.
one understanding that we can make from here is if a function is strictly decreasing or strictly increasing, then it is one-to-one function. Then it will represent one-to-one function. Okay, clear? If it is strictly increasing or strictly decreasing, then it represents one-to-one function. Okay. So now just counter example for that. Okay. So that you can understand this better. Now look at this. I have one more function, something like this. Okay. And my function goes like this, and it is stationary for some times, and then it goes like this. Maybe let's not draw like that, but something like this. Okay. Is this does this passes the horizontal line test?
Yes,
No.
sir. It was.
No.
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 No, it doesn't.
At
No,
all
it
points.
doesn't.
Let's say this is 2. So if I draw a horizontal line over here, yes, it cuts at one place. Over here, yes, it cuts at one place. Over here, yes, it just cuts at one place. Now look at this. When I draw a line over here, right? How many places does it cut? Infinitely
Infinite.
many points.
Infinite.
Infinitely many points, right? So it fails the horizontal line test here, and therefore this cannot be one-to-one function, right? And notice that this is not strictly increasing function also, right?
Yeah.
So all
Yes.
of these are correlated, right? So now when I say that when it is strictly decreasing or strictly increasing, then it can be a one-to-one function, right? Clear?
Yeah.
So now clear with this counter example?
Yeah.
Yes.
Okay. So now having known these many concepts, let's go to the next concept. Fine. So what was the main thing that we were discussing? Let's go to our first page. So we covered, yeah, there was one more concept called exponential function. So let's just see this, okay? So you know this exponential function, I can just simply tell you over here, not exponential function, but natural exponential function. So natural exponential function are given like this, okay? So it is given like this, natural exponential function. It is represented something like this, f of x is equals to e to the power of x. Rest all conditions are same. What is the value of e? Anybody?
Yeah. 2 point.
2 point.
Point something. So is
Yeah.
this greater than 1? So e is
Yes, sir.
greater than 1.
Yeah.
If e is greater than 1, can I say that it is something similar to our this when a was greater than 1? How was the curve? Something like this,
Like.
right? So I can say that when I'm using this e to the power of x, I am basically dealing with which condition? This condition.
It's more than one.
More than 1. And rest all parameters will fit in here. Everything will be same. That's it. Okay. Clear with this? This is all about the exponential function. Natural exponential function.
Natural.
Yeah. So we discussed this, right? Now let's jump into the other concepts which are very, very important. Okay. So this is like, I'm telling you, this is going to get repeated. I always stress whenever I discuss the topic and I give emphasis to some topic saying that this is very important. You should make a note of this. Because if not in your quiz, some or the other place this is going to be repeated and there might be some 3-4 weeks on that particular contents. Okay. Okay, you understand this because I even take maths too, so I know this where it is what. So I'm just telling you that yeah, this is what is very important. So pay attention to this one. Okay, so now let's go with the next part. So now let's pay attention to this exponential, composition of function, okay? And then we can just build on this. And I think we have some time, so I can just cover this composition of function. Or should I discuss the inverse first? Or let's just go in the order. Composition of function. Pay attention to this thing, okay? If you were to ask me where are some good videos on this, so tutorial videos is must-watch video for this composition of function, because one of our instructors itself, they have discussed like how to find the composition of the domain of a composition of functions. Okay, so this is very important. Okay, so that in that aspect. So now let's go into this part. So this is like fourth topic. So what do you really mean by composition of functions? Okay, and what do you really represent by this? Okay, so now what happens is, before we were discussing our set A was going. Now look at this arrow diagram, our favorite thing, right? So we were taking inputs from here and we were getting outputs where? In B, right? This is what we were telling, no? And now I say I increase this to C. Let's say I have an element A, B, C, okay? And I get the output, let's say 1, 2, 3, 4, okay? So now what do you notice from here is, how is this? I was telling this function is mapping from set A to set B. Let's say I have one function which is mapping, let's say I have a function f which is mapping from set A to set B. So if that is the case, then all should be mapped, all the elements of A should be mapped to B, to some element in B. So if I say B is mapped to, let's say, A itself, can this represent a function?
Yeah.
Okay. Now say C is mapped to 2. This represents a function, right?
Yes.
Yes, sir.
Yes, it represents a function. Now I'm saying this B is being mapped to this C. Okay. But when I say this, if I say B is mapped to C, I have to make sure that all the elements are mapped to this C, right? But I'll make a twist over here. I'll make a twist over here saying that, let's say that I am taking the inputs from here. Let's say I have a function g of f. So basically whatever is the input, whatever is the, okay, maybe I can say like this, that is g, I have a function g which is taking inputs from my f of x. So now understand what does this means. Basically I have a function g, and what is the input for that? F of x. Now could you tell me what is f of x from this, from this arrow diagram? Could you tell me what is f of x? F of x values.
B. 1, 2, 3.
1, 2, that's it.
Two,
What
only
1,
1,
2,
2.
1, 2.
right? So this is my x and this is my y. So you see this, what is f of x? The output from this, no? So output from this is 1 and 2, right? Now I'm saying I have another function g who takes the input from my f of x. Now what is my f of x? 1, 2. Clear? You understand now?
Mm.
You understand now? And let's say I have another set of elements. Let's say I will say red, blue, okay, and I'll say green, and let's say yellow. Now what? I'm mapping this to this. Now let's say A is mapped to red, okay, B is mapped to blue, something like this. Or maybe let's say this 2 is also mapped to red. Okay. Okay. Now understand this. First of all, I'm convinced that g of f of x is basically a function, because that will contain elements 1, 2, and that is mapped, right?
Well,
Correct. So now if I have to ask you, what are the elements of, what is the elements of g of f of x? Could you tell me what is the element of f of g of x?
Red.
Red.
1, 2.
No, how come 1, 2 and all? I'm asking what is the element of g of f of x?
function g is a function.
Function, yeah, yes. G is a function and f is also a function.
Mm-hmm.
Over here, this function was taking values from x. Basically, instead of saying this x, okay, let's call this as x. Okay, so a is basically x here. So this is set x. Essentially, I should say a here, f of a. So it is taking this elements from set a. So let's, because we always deal with x, right? So let's call this as our set x, and let's call this as our set y, and something like this. Okay. So now you can understand, right? Now this mapping was from here. So now I know that my f of x values is what? Like what is the output that I'm getting from here, from AB? From the output which I'm getting from f of x is what? 1 and 2. Now I'm telling there is another function g which takes the input whatever is the output of this function. So what is the output of this function? 1. Okay. So when I put this, so what is g of 1? G of 1 is red. What is g of 2?
Red.
Again, right.
Okay. So essentially I should not say g of this thing because simply I'm just substituting into this. So I'm getting this. Okay. So now you understood this. So what is happening? I'm taking this as the input and I'm giving output as red. So g of f of x is basically red. Okay. So now this is one crude way of telling it. Now let's understanding it in a different way. Okay. Now let's bring out this machine concepts and understand. Let's say there is one machine called f. Now I'm giving an input from x. What do I get output?
F of x.
I get output as f of x. Now this f of x value is going into another machine and this machine is called as g of x, g of
G of
f. Okay, so what is happening? Essentially, this is actually getting into this machine and it is giving me output as what?
Yes.
Let's say this is another machine and this output, so this is machine G and it takes the input as f of x. And what is the output I get?
G of
G
x.
of f.
G of
This of You understood now? So
Yes.
now see when I write, so this is some notations. Okay, so when I write G of f
F
of
of
x, this is equivalent way of saying G of f.
F.
Okay, so basically this is it is same. Okay, clear?
Mm.
Okay,
Yes.
so now you have some idea about composition of function. Understood something?
Yes.
Okay, so shall we dig more here?
Okay.
In different.
Okay, so now having known that yes, you understood what is composition of function, so we are getting more deeper into it. Like not very deeper, but yeah, it's like simply we are building our concepts. Okay. Now let's say I have a function something like this. Okay, you have to tell me. Okay, could you tell me? Look at this function f of x. Let me see how many of you understood this. Okay, so now I have a quick question to all of you. Now let's say I have a function f of x is equals to x square. Okay, and my g of x is equals to root x. Okay, and now I'm asking you, what is your f of g of x?
X.
X.
So basically f of g of x is nothing but root x, and what is my function f? So it's basically root x
Whole
the
square.
whole square. And what do I get from here? X,
Yes.
right? Okay. Now if I have to ask you, so my question is, what is domain of?
domain can be anything real number.
Any real.
No, wait. What is domain of g of x? So the
G.
question is this. So your answer is R.
Natural numbers.
Your answer is natural numbers.
Yeah.
Your answer is some fractional values or whatever. So could you tell me
Natural
what is,
numbers. Natural numbers.
why not R? Because this is the x you get. So basically not g of x. So I'm sorry. It should be f of g of x. I'm so sorry. Now it will become difficult. If g of x was so easy to say. Here, can you tell me what is the domain of f of g of x?
R.
R, right? All of you convinced? F of g of x is x, right?
X, any
Yes.
real number.
X can take any real value, is it?
No, it can't take a negative.
Negative value.
It cannot take negative values. Why?
Root x g of x is
Hmm.
of g of x. G of x is negative.
Root of X.
G of x is the sir, output of g of x is the input of f of g of x.
Yes. You are getting somewhere. Yes.
Mm.
So you are getting you are understanding this.
Yes.
Even though f of g of x is x, right? The domain is not the same as our. Basically, this is also a polynomial, right? The domain is not directly depending on this, but it is depending on the input values that you're giving, right? Right? Okay, so now let's understand this. Let's discuss more on this. So what is the domain for this f of g? Is it R? No, it is
Natural.
natural numbers, but how? Let's understand this. Even though I told it in a crude way, but let's understand this in a better way, right? So now first let's understand this. First of all, you think of our machine, just the way I was telling you, but this is not the way you should approach a question. This is just for explaining purpose I'm telling you. I'll tell you how to approach a questions, okay? I'll tell you in a while, but this is just for the explanation purpose I'm telling you, okay? But you will never approach a questions like this in your examination. This is just for the understanding purpose. I'll tell you how to approach in your exam, okay? So basically, what is when I say f of g of x? So basically, inputs are coming from x, right? Right, and it is going where in this machine g, and it is giving me output as g of x. Correct?
Yes.
Right? So basically, I can just simply okay. So let's this be g, but again, I'll have to tell you what is that happening there, and this goes to machine f, and what is the output you get? F of g of x.
G.
Now understand this. This x cannot take, this machine cannot take all the values of x, right? This machine take only what values of x? This is root x, right? So root x, what is the domain of root x?
Greater than or equal to 0. That is known to be
What is the domain of x?
0 to infinity positive.
0 to infinity. It cannot be negative. If I give root over minus 2, then what is the output? This becomes a complex. And complex is something we are not dealing with. We are talking everything in real numbers, right? So therefore, this will go invalid, right? So what is this machine can take? This machine can take only values from 0 to
Max.
infinity, right? It can take when x can take only values between 0 to infinity, and where x is equals to, where x belongs to any real number, right? But between this, it has to fulfill this criteria, right? X is in 0 to infinity and x can go to any values, right? So now this machine will give me some output based on this parameter. What will be the output I get? Root x. Now this root x is the input for this, right? Right? So this root x is input for this. So eventually what are you getting output? You are getting x as the output, right? So this you get it as x, right? So now when I ask you in general, what is a domain of f of g of x? So essentially you should say whatever is the input from here, that becomes the domain, because this is what it is getting consumed in the process, right? So what is the domain? X belonging to 0 to infinity is the domain for this. This is the domain. Okay, all of you clear? Clear? Because
Yes, sir.
now you can think this as an
And range will be real number.
And range will be real number. That is again hard to say, because that will something depend on the output what you get. Again you can say real number, but again that will be limited, right? It
So
will
the
not be
initial
all real
input
number.
for G
Hmm?
in this map, sir, initial input from for G is coming from f of x.
Sorry.
The
Yes, yes,
initial.
yes. So
Okay.
if you see, if you look into this part, this entire thing, I can club this as one machine, and I can say that this is f of g, right? And what is the output you get from here? X. So what is the input that you are getting? This is the input that you are giving to this machine, and what is the output you are getting? X, right? Clear now?
Yes, sir. Yes, sir.
Okay. So now, having known that you understood so much, I will just ask you one quick question to all of you and just try to give me the answer for this, okay? So, okay, fine. So now just quickly let's understand that whatever we have drawn, how will that graphically look like? Somebody was asking me range and all that, right? So f of x, g of x was what? Root x. Yeah, so basically, yeah, so fine. And then I was asking you to find out what is f of g of x, right? So g of x was basically x, right? How will the graph look like for this one? Could somebody tell me how will the graph look like for this? F of g of x?
Straight line.
Straight line.
Straight line passing through origin, it can be like this. Sorry.
Yes.
It can be like this, is it?
Yeah.
Okay.
No.
But notice one thing. It cannot be like this, in
No.
fact. Why? Because you see this. What was the domain of f of g of x? Which we
Zero.
found?
0 to
0 to infinity. But what about this curve? This curve is taking inputs from minus also, right? So this cannot be that part, right?
Yes, sir.
Understand? So what will be the curve for this f of g of x? It is going to be from here to here. That's it.
0.
0 and
0 to infinity. What is the range for this now? It becomes easy to tell. What is the range?
0 to
0 to
0 to
infinity.
infinity. It is not r. It is not r. Understand this. The output is 0 to infinity. And what is the input? 0 to infinity. Clear?
Yes.
Clear?
Yes.
So now you understood. Now this is something we understood. Okay, what is this composition of function doing, right? It is tweaking your functions, right? It is merging two functions basically. And the
function.
characters, yeah, so two functions and with some conditions, right? That is something we are noticing, isn't it? Okay,
Yes, sir.
right. So I
Sir,
think you,
sir,
yeah.
and if we write f of g of x, so the first one to be considered is g of x, and then we apply f of x,
Yes,
right?
yes.
Yeah, in
Now,
one of the practice assignments, there was a wrong wording regarding this.
okay, so you can just highlight that and put
Yeah.
it in the forum or discourse or somewhere, anywhere.
Okay, they've written as choose first one and then second one, and then and they have written as f of g of x, but that is not the case. Because
Okay, you can just highlight and send it to us, and we'll make that correction. Okay.
okay.
Okay. So now what is this g of f of x? So you know that whenever we are writing like this, it essentially means g of f of x, right? So what is g of f of x? So what is f of x value? X square, right? So what happens here? This is root over of x square. What is the output you get?
x.
X.
X or plus or minus x?
Okay.
X.
Plus
So
or
you get
minus
modulus
x.
of x basically. So this will be plus or minus x, right?
Yes.
Okay, so now we understood this part. So you see this, it changes, right? Because you are changing the input values altogether. Now, I would, if I take it more here, it will be very difficult for me to cover the next concept. But I'm pretty sure that if you watch one tutorial, you shall be able to understand this exponential function. I can just highlight to you which is the tutorial. Is that okay, or should you want me to explain this here more on this exponential, basically this composition of function? What I would suggest is whatever the basic criteria was needed for understanding this composition of function is done. But there are two conditions that you will have to understand it. There are two cases, and these two cases is something dealt here very elaborately. And I would be, if you can see that, it will be very good. I can say it's in the tutorial of our portal. Do you want me to mention which tutorial is that?
Yes, sir.
Or we can, or anyways, you guys watch all the tutorial, right?
Yes, sir.
Yes, yes. We
So
have
I'll
to
not.
watch.
So you can watch it there, and I'll leave that thing here, okay? Even though if you have a doubt, we can see later on, okay? But for time being, I will not go much into this. But there are some conditions which is very well explained in that tutorial. So if I repeat this, it will be the same thing I'm doing here, okay? So let me not do that here and use our time in a better way. Okay, so but that is must watch video, because what I have given, whatever I told you is just a conceptual clarity of this. Okay, that is the most important thing. And if you still don't understand there, you can ask me in any of the sessions. I'll explain you how do you really find the domain of the composition of function, because this is something very important. Okay, let's say you have a function like this. If I give you a function f of x is equals to some functions like this, let's say what you have studied in your polynomial, let's say e to the power, not e to the power, but let me give 2 to the power of x square. What is the domain of this function? Right? Questions like this, right? Or maybe x times x minus 1 times x minus 2 times, okay, what is the domain for this particular question? Right? So these kind of questions, right? Or like any other things. This is something very well explained in the tutorial. You just watch it once, okay? That will suffice the need for this thing, okay? And then all you have to do is practice. If you are not able to understand, anyways, we can meet in the next any of the live session. You can ask any of the course instructor. They'll explain you what is this composition of function, and they'll definitely discuss that two cases. Fine. So I'll just leave that here, and I will quickly go into this inverse part. Okay, so the next topic is, because I'm just trying to obey this time, and I know that this quality material is there in our portal where you can learn this from. So at least I'm not feeling that I did not thought anything.
Sure, sir. We understand,
Yeah.
sir. We will
Yeah.
go to the inverse function.
Yeah. So here, just a minute. Let's understand this inverse function. Okay. First of all, one disclaimer over here would be inverse of a function exists only for one-to-one functions. Okay. If a function is one-to-one, so first of all, let me just write it down. If if a function, okay, if a if a function is strictly increasing or decreasing, right? All of us are convinced with this, no, from the previous what we discussed. If a function is one to one, how do you check this one to one? Horizontal line test, right? If a function is one to one, either the function is strictly increasing or decreasing, right? If this is happening, then inverse for this function, inverse for this function exists. Okay, so inverse exists only for those functions which are one to one or which are strictly increasing or decreasing type. Okay, clear with this? So inverse exists only for those functions which are strictly increasing or strictly decreasing, or in other words, I can say that if a function is one to one, simply I can say that inverse exists for that particular function. Clear? All of you clear with this? Okay, so this is one thing that you should have taken it from here. So well, having known that you understood, maybe I'll just not erase this, I'll use some other thing. Okay, so now how do you check whether the function, how do you actually find the inverse of a function? Or basically if I claim some function to be an inverse, how do you really check? So in a crude way, what do you used to do in our school days was, if I tell you, okay, y is equals to x square, or not x square, maybe I can give you some other function, something like okay, maybe I can just give it like x square plus 1. Okay, if something like this is given, if I have to ask you, okay, what is inverse of this function, what do we used to do? Can anybody tell me? We used to
Multiply by -1.
multiply with -1. Not exactly,
We
but
will,
what do you really do?
we will express x in terms of y.
Correct. So what you used to do is, what we used to do in our school days was, because even in school days we used to find the inverse of a function, right? So what do we used to do in those days? We basically used to take, we used to replace x with y. So you can say that replace x with y, and find y, right? So how do you do this? If I'm replacing x with y, so what happens? So then y becomes x essentially, right? So this is going to happen like this. So y is equals to x, and this y becomes y square plus 1. And then I'm saying find y. Okay, so now you will find out y. So how do you get y? Now I'll just take this to the other side. So this is going to be y square is equals to x minus 1, right? And y is equals to root over of x minus 1. Okay, you can definitely ask me plus or minus, but I'll just simply assume this is plus. So this is what we used to do, and we used to claim that this is the inverse of this function. So this y over here, what you get, this y is inverse of, so this y is basically written in terms of what? This y itself is called as inverse of this particular function f of x. So if I have to not say this, let it be y only. This y, what you get now, is basically called as inverse of f of x. Okay, so you have some understanding like this. Okay.
Yes, sir.
So if this is there in our base, I will build up more on this, saying that what do you really do? Okay, how do you really check? What do you really mean by inverse of a function? Okay, so the condition for that inverse of a function is, so maybe a formal definition, if f of g of x is equals to g of f of x which is giving me x, then g of x is inverse of f of x g is inverse of f of x, so which you can write like this. Basically, you can write g is equals to g of x can be written as f inverse of x. Okay, so clear with this? Then g of x is inverse of f of x. Also, f of x is inverse of g of x. So each of them are inverses of themselves basically, right? So when we took that previous example where we got this x minus 1, something like this. Okay, so forget about this. So over here, when we say this f of g of x is equals to g of f of x is equals to x, when you get conditions, when this condition is fulfilled, basically when f of x, when f of g of x and g of f of x, you remember when we took that previous example where we told that our f of x was x square and g of x was root x, right? And we found that g of f of x we found, right? And we got answer as x, isn't it? But when we did this f of g of x, what was the output we got that time? Plus or minus? What did we get?
Plus or minus root x.
Plus or minus root x. So are they both same? This is x and this is plus or minus root x. Are they same?
No.
They are not same. So they were not inverses of each other. Okay. So when do you say inverses? When f of g of x and g of f of x is giving me output as x. If this is happening, then you say that g of x is inverse of f of x or f of x is inverse of g of x. Okay. So when you say f of x is inverse of g of x, then how do you write? How do you write f of x as? Just simply like this, f of x. You inverse, you write it this way, okay? So clear with this much thing? So only condition is this part, that f of g of x should be equals to g of f of x, which should give me x, okay? Then basically you call g of x is inverse of f of x or f of x is inverse of g of x. Clear? Clear? If not
Yes.
clear, if not clear, we'll discuss more examples, then it will be clear, okay? So now let's discuss some of the examples and then see what is that we really mean, okay? So now let's take one example. And let's take example as this. Okay, find inverse for this. So if I have to say this, my f of x is, let's say, x square, okay? And I'm asking you to find out the inverse of this. Find inverse of x square. Find out. Can you quickly do this? How? What will be the first thing that comes to your mind? Replace f x with y and f of x with some other, let's say x, right? And get the answer. What do you get? Can somebody quickly tell me? Hmm?
Tax.
Okay, so over here, maybe since we are dealing with these kind of things, so let's go with this. You put x with y and f of x with something else, maybe x. So over here, let's say your f of x is x square and g of x is y. Now you should be able to do it. Now find out the inverse of x square. Okay, so difficult to do. So if I have to ask you, okay, find the inverse of f of x square, so how do you really do this is basically look at this condition. I'll first take my first part. This is f of g of x, which is equals to x. So what is f of g of x? F of what is g of x? G of x is y,
Y.
which is equals to x. This is what I'm claiming. So what is f of y? What is f of y?
X square.
Y. So
Oh, sorry,
basically,
y
instead
square.
of x, I'll be writing this y
Y
square is
square
equals to x, and then I'll find out what is this y basically. So what is this y I get from here?
root x
So
plus or minus x.
y I get is plus or minus root x. So I'm getting two values here y as a y, right? So y can be either plus root x or y can be minus root x, right? So I will check for both of these. So what will I check? So if I have to see that this is an inverse, if I have to claim that g of x is inverse of f of x, so what is my claim? Basically, look at this part when we were talking, we were looking at this definition. We say this f of g of x is equals to g of x, which is equals to x if and only if this will happen. If this is happening, then you say that g of x is inverse of f of x. Can I, with this data, can I say that g of x is inverse of f of x? Can I say that?
No, you cannot say
I
so.
cannot say that, right? I cannot say that g of x is inverse of f of x because there are two values still, right? So to some of you, like from our school days, what we were doing, we were actually replacing what? We were replacing x with y, right? This is what we used to do, isn't it? We did the same thing here as well. What did we do? F of x, we took it as, this was initially what? It was initially in this form, and then you replace the value. So what do? X into y square, right? And then you start solving. This is the same thing. Okay. If you're trying to correlate from your school days. But look at this, even there also you would have got this plus or minus root x, but we used to ignore this and we used to just take plus and we used to say, okay, this is the inverse. But this is not the reality, because you see this is something, it has to happen. When do you say that this is inverse of this? When this condition is also satisfied, when f of g of x is x, also g of f of x should give me x, right? If this is happening, then only I can say that g of x is inverse of f of x, correct? Right? All of you with me?
Yeah, okay.
Okay. So now let's see that. So what is g of f of x? So now g of f of x, right? So now g of, what is my f of x? What is my f of x? X square is equal to x. So what is g basically for me?
Y.
Hmm? Now I'm just simply trying to verify whether g of x is inverse at all or not. What is g of x you got from here? There are two values of g of x. Basically you got root x or minus root x, right? So simply put it here. I'm just trying to verify it, this thing, whether my LHS is equals to RHS or not. Okay, so if I just take LHS in this, what is my LHS? So what do I get? If g of x square is what? I'll just simply put it into this, right? So if I put it here, if I give it here, so what do I get? X square, it is x square is getting into this function. Let me take okay, so maybe I can just simply write down here. There are two cases.
G of
Then,
root x
okay,
square.
maybe I'll just simply write down that g of x is x square, and no, root x, and over here g of x is
Minus
minus
root
root
x.
x, right? If this is my g of x, then what do I get if I simply substitute this? What is g of x square
X.
then?
X, sir.
Root over of x square, which is x, and from here what do I get? G of
X.
x square, what do I get?
X.
So minus root over of x square, which is giving me minus x, right? Right?
Yes,
Sir,
sir.
minus to minus plus no, sir.
How minus into minus? This is outside. It's minus root x, right? And you are substituting this x square into this. So root minus root over of
The
x
bracket
square.
also will come inside
No.
the minus will come inside the bracket.
This x square will go into this. That's it. And this entire thing will remain same. You getting it? G of x is what? Root over of x. And instead of x, you are writing what? X square. That's it.
Oh.
Right? So what do you get? So can
So,
I?
okay.
So
Okay.
if I have to tell that, okay, this is my root, which is inverse then basically. What is inverse of? So if I have to tell from here, and y has got two values, that is root x or minus root x, which among them is inverse of this? Root x or minus root x? Which is inverse? Which is inverse of x square? Root x or minus root x?
Root x.
Root
Root
x.
x. Because when I'm taking root x, when I'm taking g of x as root x, I'm getting output as what? X, right? And that is what I have to do. When f of x, when f of g of x and g of f of x is equal to x, if they are equals to x, then only you say they are inverses of each other, right? So if I have to ask you what is inverse of x square, what do? You essentially first find out, okay, what is your y, and assuming that g of x is y. So you get, let's say, two values. Then you will check these two values among which two values which will give me x. So I'm seeing that when I'm taking root x, when I'm taking g of x as root x, I get that output as x. But when I take minus root x, it does not give me my x. It gives me minus x. So this does not fulfill this condition. And therefore, I can say that this is not the inverse, but which is inverse? Root x is inverse. Okay, it is too much. Should I repeat this? Should I repeat this?
Yeah, 1 second, sir, please.
Okay. So whenever a question is asked, whenever let's say a function is asked, like normally in your examination, that will help you out better. If I say, okay, find the inverse of a function, maybe I give you a function something like this. Okay, so if I say that find the inverse of a function x square. Okay, so what do basically? You first take this function f of x is basically you take this function x square as f of x equals to x square, and you take the other function g of x is equals to y, and you go with an assumption saying that, okay, g of x is my inverse of f of x. Okay, you go with that way, and now what do? You simply substitute this and find out what is your y. You find out, you say that, okay, this any of these will be my inverse of this. Okay, either it is going to be this or this. Okay, so what you are doing is basically you are taking f of x is equals to x square. If I have to find out the inverse of x square, okay, fine, you say, okay, this is my x square. Now I say that g of x, let's say that is the inverse of this particular function, and then you take that g of x is equals to y. Okay, and then what do? You put in this formula, you take this condition f of g of x is equals to x, you take it anyway, but you have to make sure that the other condition is being satisfied too. So what do? You simply substitute this into this formula. This is f of g of x is equals to x, and you put that, and then you get the answer. Let's say something like this. Okay. Let's say if you got simply one value, root x, you could have simply told, okay, the inverse for this is root x. Since you got two values over here, therefore you are checking it here. But you have just one value, then you can simply say, okay, this is the inverse for this. And how do you verify this? Take the other conditions, whether that is inverse or not. Just take this condition, the other condition, and just simply try to put this into that. If I was claiming, okay, root x is this, so essentially I took as what, g of x is equals to y, and I told, no, that we will get some values, and that we are saying this is the inverse for this. So how do you check whether this is inverse? When you see this condition is being satisfied, then you say that yes, this is inverse for this particular function. Okay, so that's how you go. Okay, so now when you just simply substitute these values into this, you find that this is what you get. Okay, and you say that this is the inverse. All right, so I guess it's getting too much now, but
Sir, before that, sir, what is the definition of inverse of a function, sir? That
just a
itself.
Okay.
Hello.
Sir, you are not audible.
sorry. Yes, I could not hear because I just got I had something to ask somewhere. So yes, what is that you wanted to? What is that you were asking?
What is this definition of inverse of a function?
Okay. So basically what does it means is, if f definition says what, if f of g of x and g of f of x is equals to x. So maybe I'll just erase these parts and I'll just take simpler example and then explain you what it is, then you should be able to understand. Okay.
No, but g of x.
I'll explain you this. I'll explain
Sure,
you
sure.
everything.
Sorry, sir. Sorry, please.
Uh, you see this, first of all, you know this, what is f of g of x? How do we calculate this f of g of x is something we know, right? If function f of x is given, let's say something, and then g of x is something given, then you can calculate what is f of g of x, right? You can calculate that, no?
Yes, yes.
You can also calculate what is g of f of x, correct?
Okay.
Okay, you can calculate both of these, right? You will get some expression. Let's say the expression what you get is x, and over here also whatever you get is x. If both are giving you x, then you can say that g of x is inverse of f of x, or f of x is inverse of g of x. Clear?
Up to
Yes.
that I have understood, sir. But
Up to that you understood. Now I'll come
no,
to
no.
that.
My question is, what is the inverse at all? First of all, that is what I am not able to. Why
I'll
we are
take you to the
finding inverse?
graph part. Yeah, I'll take you
Yes,
to the
sir.
graph part in a while. But first get convinced here, then I'll take you to the graph part. And when I'll tell you graph, it will become more clearer. So just pay attention. Let's say my function f of x is x cube, and I'm asking you to find out its inverse, right? So find its inverse. Okay. So what do you say when you find the inverse? What you need? You need one more function. You say g of x. Let's say this is y. And you go with an assumption saying that, okay, let's say g of x is basically an inverse of f of x. Okay, when I tell you find the inverse of x cube, then you will actually have to find the other function, right? You will actually have to find the other function, isn't it? So how do you really find out that function? You will say, okay, that function is y basically, right? So now what you will do, how do you do that? So you will find out what is f of g of x, right? So what is, as per this condition, I'm taking these pairs, right? So f of g of x is basically, and see, when this is happening, then you will, whatever the value you will get in terms of y, that will be your inverse, right? It's simple. So now what, we will simply substitute into this. Now what is f of g of x? Essentially this means this, right? What is g of x? Y. What is f of y? Y cube is equals to x. You want to find out y, no? Because y is the inverse. This is what we are going to do, right? You say g
Okay.
of x is inverse of f of x, right? So you are eventually finding out what is your y. So y is equals to x to the power of half, 1 by 3.
1 by 3.
Okay. So now this is something you get as y, right? So what did you get? Inverse of x cube is what? X 1 by 3. This is the inverse for x cube, right? You got it? Okay.
Yeah.
But again, do not be sure about it. Now you need to verify whether is this right what you got. So how do you confirm whether, so maybe you can confirm this. To confirm y is equals to x 1 by 3 is inverse or not. How do you confirm that? All you
Yeah.
have to do is now take the other pair
Put
and
it
just
in
see
f
whether
of
you get.
x.
Just you will have to verify that. What is your g of f of x giving you, right? So now what is that we get? What is g of f of x?
Yeah, of f
Just tell
x
me the
cube.
value. What is f of x basically?
X cube.
X cube. And what do you get from here? When you substitute this into y, now this is your g of x, right? So put that into that. So this is going to
X
be
cube to the power of
X
1 by
x to the power of 1 by 3 to the power of 3.
so what, x cube to the power of 1 by 3,
1 by
and when you simplify this, what do you get? X.
X.
Did we get back x?
Yes.
So that means whatever we got over here is inverse. Understood? Clear now? Clear?
Yes,
Yes,
Yes.
sir.
sir.
Yes, sir.
Okay. So this is what you will do. Whenever a question is given, you will say, okay, fine. The inverse for this is g of x is equals to y. Start solving it. You got a single value over here when you solved it, right? And that is why, and we confirmed it also. Okay, what is the inverse? But the moment I gave it x square, we got two values of y, isn't it? At that time when we were discussing, we got two values
Plus
of y,
and minus.
root x and minus root x. And then we were confirming which among them is actually inverse, right? So at that time I took two cases and I was trying to fit in there. So when I was taking root x, for that I was getting as minus x, and when I took it minus root x, I was getting minus root x. In that case, which should have been my inverse? This would have been inverse,
Root
right?
X.
Because, right? That is how we were getting it. Now let's understand this graphically, which is very important, and that is how this concept will be clear to you. Okay. So now understand this. X cube graph is what? Something like this.
Quadratic.
How x cube is
Cube,
quadratic?
cube. No, x
Cubic
square.
graph is something
Sorry,
like
sir.
this. Okay.
Cubic.
Okay. Now, first of all, look at this function. Is this strictly increasing?
Yes.
Inverse exists for this, right?
Yes.
Inverse exists for this if it is strictly increasing, isn't it? Clear?
Yes, sir.
Yes, yes.
Yes, sir.
Inverse exists. That means we got the inverse as what? X to the power of 1 by 3, right? Okay. So now we will draw the graph for that in a minute. How will the graph of inverses look like? But before going there, quadratic function. Look at the quadratic function. When I give it as a y square, x square, how will the graph look like for x square? Okay. Now, is this strictly increasing function or strictly decreasing function?
No.
No.
It is not.
Decreasing and
Therefore,
increasing.
therefore, we could have not founded the inverse for this,
Yes.
right? But we could have founded the inverse by certain limitations. You saw at that point we got two values of y, isn't it? But which is the one which is giving you inverse? That is what you will have to do. So in that case, you would notice one thing is when you take root x, you are basically finding the inverse for only one half, not the two halves. So now understand one more thing. Inverse of a function. So before coming here, just a small recap to all of you. Okay, just a small recap. Okay, so pay attention to this part. Okay, so it's just a recap which I'll maybe write down here. Okay, so now just a recap. Okay, when do you say a function is one to one? Not one to one, but basically when do you say a function is even function? When do you say even function? When it is symmetric about y-axis. Now, if I have to draw some even functions, so basically if I have to say even functions are symmetric to y-axis. So basically you take any even function. It's not even degree. I'm talking about even functions. What is the condition for even function? When f of minus x is equals to f of x, then you say it is an even function. Okay.
Yes,
So
sir.
what is the condition for even function? Now, if it is an even function, it will be symmetric about y-axis. Look at this curve. Is this symmetric about y-axis? The one half is symmetric about
Yes,
the
sir.
other, right? So even functions are always symmetric about the y-axis. Odd functions are symmetric about origin. Symmetric about origin. So one example for odd function is x cube. So if you take origin as this thing, then you will see this half and this half is basically symmetric. When you talk about inverse, right? So inverse functions are symmetric about y is equals to x. So if I have to tell you that, let's say this is one curve which is going something like this. Okay, this is one curve which is going something like this. And if I have to ask you what is inverse for this function, let's say this is my function f of x, how will the inverse of this function look like? So basically all you have to draw is first do y is equals to x. So y is equals to x is basically a line passing through origin like this, right? All you have to do is draw a symmetric line about this. So symmetric line from this is what? Symmetric line for f of x along y equals to x is what? Basically something like this. All of you clear?
Yes.
So
Yes.
this is, let's say, our g of x, or g of x is nothing but r f inverse of x. So you see this is something I have just drawn the symmetric for this. So this curve represents your inverse curve. Now let's quickly go to this part. Now look at this. My function, this is my function x cubed. Now what is the inverse I got? X to the power of 1 by 3. So now what, again, if I have to draw this function, what will I do? I'll simply draw y is equals to x. First, this is because this is something which is going to act as a mirror for me, right? So now this is y is equals to x curve. Now all I have to do is just draw the symmetric about this. So if I just draw the symmetric for this, how will that symmetric curve look like? So if I have to draw the symmetry for this, is how is that symmetry thing going to come? Something like this?
Yes, sir.
Maybe I should use some different color. Yeah, let me take red. So this is something going to be like this. And this part is something going to go like this. Right? So this is the curve for x to the power of 1 by 3. Clear? Well, this is, it appears as if going towards x-axis, which is not right. It goes like this. Okay, so clear now? So basically a line or basically a inverse functions are symmetric about y equals to x. Okay, so whenever you want to draw any curve is given, and if you are asked to find out, okay, what will be the symmetric for this, then all you have to think of is this one. Okay, now look at this part. Now if I have to draw the symmetric for this, now we know the inverse for this particular function. Now this was x square. What was inverse for this particular function? Root x. How is the root x graph? Root x graph is something like this. Now again, if you want to actually find out, then you can really do this. This is y is equals to x. All I have to do is just draw the symmetric about this. So this red curve, what you see is basically your root x curve. You can just draw it in a Desmos and see it will be like this. Okay, clear?
Yes, sir.
Okay. So now
This will not come in the this side, sir, minus x side.
it will not come. Now I'll ask you why it will not come. Okay. It will not come to this side. It's just because I have to restrict the domain, right? You understand what I'm trying to say?
Yes, correct, sir.
Yeah, because if my domain is from 0 to infinity, then yes, this is strictly increasing function, for which I can find out, okay, what is my inverse for that. Clear?
Okay.
Clear? All of you clear?
Yes. Domain is different.
Yeah. So that's how you actually get the inverse for these functions. I think you need more touch upon these things, like the inverse. You try to take up some questions and start doing it. Maybe do more graphics. And I had 2 hours only in which I had to discuss all this thing in this way. We could have done it much better, but it's okay. These things can be more clearer when others instructors are taking it. So that's fine. And I think we can just wind up our session today. Okay. But we can see, I mean, I just tried to touch upon the entire contents of this week, and that's why we could not cover much. I mean, I should have even given you more examples over here just to illustrate what I'm saying it. Then it becomes clearer, because you see, it's in mathematics, when you say something, the definition, that is one part of understanding. But illustration is the most important, because that is where your concepts get clear. When we give you some 5-10 examples, and then we give you a counter examples, that's how we understand any concepts, right? It's not just, okay, this is the concept done. It's not like that. So what I have done is I have deprived myself with less examples here, but it's because we had to obey time. But it's okay. This can again be supplemented in other sessions. So pay attention to these things, because these are very important, especially the composition of function and the inverse of a function. Do pay attention to these. Okay, because what I feel is you need more examples by which you can understand this better. Okay, so you better give emphasis to these things, okay, whenever you are solving it and whatever. Okay, so I think we can just end our session now. So thank you all and have a good day.
Thank you to you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you so much.